Okay, so hello everyone. I guess it's okay. So hello everyone. This will be the review for TIMO mock exam 2023 for secondary two, and I will be your lecturer for today. I am Sir or Coach Genesis. Okay, so let's start with the first batch of questions for the first category, which is logical thinking. So number one, 18th of November 2019 or 2019 is Monday. Which day of the week will 18th of November 2029 be? Okay, so the first thing that we will do here is to identify which years are leap years and which years are just regular years. So we actually have seven 7 years that has 365 days, while we have 3 years that have 366 days, so which we call leap years. So those are 2020, 2024, and 2028. So since we have 10 years here, so we could just subtract 10 by 3 in order to get the number of regular years. Now, since we are talking about day of the week, then we can apply congruence modulo 7, or basically just divide by 7. Okay, so the first thing here is 365. Now 365 divided by 7 will give you a remainder of 1. That is why we have 1 here. Now, next is we have 7. Now, actually, we have 1 times 7 is 7. Now, 7 under modulo 7 is just 0. So we could just directly write here 0. Um, wait, 0. Sorry about that. Okay. Then we have 366. 366 divided by 7 will give you a remainder of 2. That is why we have here 2 times 3. Now 2 times 3 is equal to 6 modulo 7. So we could just keep this part right here. And then we could just have 0 plus 6, which is equal to 6 modulo 7. So this means that we will move 6 days from Monday, which means that we have Sunday, 6 days after Monday. Okay. So that is number 1. Now there will be no additional number of days because here we have the same date, November 18 and November 18. So we'll just count the number of days based on the number of years between the two. Okay, so that's it for number 1. Okay, next we have number 2. There are 25 white table tennis balls, 25 orange table tennis balls, and 8 blue table tennis balls mixed together. If you want to choose 2 orange table tennis balls and 2 white table tennis balls from the pile of balls at random, at least how many table tennis balls are needed to be taken? Okay, so here we must use, of course, worst case scenario. Because what we want is to ensure that we have 2 orange table tennis balls and 2 white table tennis balls. So in this case, we first pick the blue table tennis balls, because this will not satisfy any of the conditions in the problem. So you have 8 blue, and then we have to pick 25 white or orange table tennis balls. Now, as you can see here, we have 25. They have equal number of balls here. And we also need to pick two for each. So it doesn't matter whether you pick 25 white first or 25 orange table tennis balls. So you have 8 blue, and then we pick 25, let's say white, let's say 25 white balls. Okay, so we have already satisfied this condition here, two white table tennis balls. So that means that in order to satisfy all of the conditions, we only need to pick two orange table tennis balls. That is why we have two orange here. Okay, so that means that we have 8 plus 25 plus 2, or 35 balls to pick out of all a total of 58 table tennis balls. Okay, so that's it for number 2. Okay, next we have number 3. Robert goes 25 kilometers north, goes 12 kilometers east, and then goes 9 kilometers south. How far in kilometers is he now from the original position? Okay, so what we will do is we try to create a rough sketch on the path that is made by Robert. So we have here 25 kilometers north. So basically something like this, right? 25 kilometers north, and then 12 kilometers east. So less than half, something like that. And then 9 kilometers south. So something like that. So that means that the distance that we must compute is from the original position to here. Okay. Now, notice that we can actually use the length here and reflect it here, because they will have the same distance. So since this is 12, then this must also be 12. And then this is actually a right triangle. So we can use Pythagorean theorem for this one. Now, the problem here is, what is the length of this one? So we have 9 here, and we have a total of 25 kilometers here. So this and this right here is actually equal. So that means that this is 9. Therefore, the length for this side right here will be 25 minus 9, which is 16. So we will use Pythagorean theorem using 16 and 12. So we have square root of 25 minus 9, so that is 16. So square root of 16 squared plus 12 squared. If you simplify this one, you will have square root of 144 plus 256. So I just switch that. It doesn't matter because addition is commutative, which will then give us square root of 400 or 20. So that is the distance from the original position to Robert's current position, 20 kilometers. Okay, so next we have number 4. So given that A is to B is equal to 7 is to 4, B is to C is equal to 1 is to 3, C is to D is equal to 4 is to 1, and D is to E is equal to 2 is to 3, and A plus B minus C plus D plus E is equal to 350. What is the value of B? Okay, so the first thing that we will do is to establish the whole ratio. A is to B is to C is to D is to E. So we can do it slowly, so or one by one. So first we establish the ratio A is to B is to C. Now take note that we have 7 is to 4 and 1 is to 3, right? So the first thing that we will do is get the least common multiple of 4 and 1, because that is these are the values for B. So yeah, so LCM of 4 is to 1 is 4. We then adjust all the other values. So since B is 4, then of course A will be 7, because 4 divided by 4 is 1 times 7 is 7. Next, 4 divided by 1 is 4. Now 4 times 3, so you have here 3 times 4. If you simplify that one, that will give you 7 is to 4 is to 12. So that is A is to B is to C. Next, we establish the ratio A is to B is to C is to D. So since you already have A is to B is to C, you write here 4 is to 1. Because this is the ratio for C is to D. Okay, now we get the LCM of this one. So the LCM of 12 and 4 is still 12. That means A is to B is to C will not change in value. 7 is to 4 is to 12. However, for C is to D, we have 12 divided by 4, and then you multiply by 1. So 12 divided by 4, that will be 3, multiplied by 1, that will be 1 times 3, which will then give you 7 is to 4 is to 12 is to 3. And finally, we establish the ratio A is to B is to C is to D is to E. So we have here, we write D is to E again here. So we have 2 is to 3. Now, what is the LCM of 3 and 2? That is 6, or 2 times 3, right? So the next thing that we will do is we divide. We divide 12 by 3. So 12 divided by 3 is, no, we divide 6 rather, this one. We divide 6 by 3, that is 2. So that means that the whole ratio A is to B is to C is to D will be multiplied by 2. So you have 7 times 2, 4 times 2, 12 times 2. And of course, 3 times 2. And for D is to E, 6 divided by 2 is 3. 3 times 3, there we have it, 3 times 3. So simplifying, you will get 14 is to 8 is to 24 is to 6 is to 9. Now, observe that this is actually not, all of this is not actually a sum. One is a difference, which is C. So what we can do is we divide 350 by 14. So here 14 plus 8, and then you subtract 24 because you have minus C, plus 6 plus 9. That will be equal to 350 divided by 13. So this is somehow what we call the common ratio factor, in which you will just multiply 350 over 13 to each of the values of the ratio. However, the question asks for the value of B. So as you can see in the ratio, B is 8. Right here, B is 8. So that means you multiply 8 by 350 over 13, which is equal to 2,800 over 13, or 215 and 5 over 13. So that is the value of B for number 4. Okay, so let's proceed with number 5. According to the pattern shown below, what is the number in the blank? Okay, so we have 1, 1, 2, 7, 34, 203. Okay, so what we did here is we have 1, I multiplied 1 by 2. So this is the first value, right? 1 multiplied by 2 and then subtract by 1. That will be 1. Next, 1 multiplied by 3 minus 1, that will be equal to 2. And then we will use 2 again here. So you have 2 times 4 minus 1, that is equal to 7. So as you can see, the pattern here is we get the current term, which is, let's say, the first one, which is 1. We multiply each succeeding term, with increasing value here. So we have 2, 3, 4, and so on. And then all of the values here will be subtracted by 1 after. So in this case, let's say we have 1, we have 2. So what do you expect next? We have 7 multiplied by 5 and then subtracted by 1. So as you can see, 7 multiplied by 5 and then minus 1. So that is 34. Next, 34 multiplied by 6 minus 1, that is 203. Now the question asked for the term after 203. So that will be 203 multiplied by 7 minus 1 is equal to 1,420. So that is the number in the blank, 1,420. Okay. And for number 6, there are some chickens and goats in a farm. The number of chickens is 3 times the number of goats. They have 120 legs in total. How many chickens is or are there? So let C be the number of chickens and G be the number of goats. Now here in the problem, it says 3 times the number of goats. The number of chickens is 3 times the number of goats. So that means that C will be equal to 3G. It also says here they have 120 legs in total. So that means that we have 2C plus 4G is equal to 120. You can simplify this, or you can just leave it as it is. Next, we solve for G in terms of C. That way we can solve for the number of chickens immediately after. So you have G is equal to C over 3. And then we substitute that to the second equation. So we have 2C plus 4 times C over 3 is equal to 120. We multiply both sides of the equation by 3 in order to get rid of the denominator. So we have 6C plus 4C is equal to 360. Simplifying, you'll get 10C is equal to 360. You divide both sides by 10, and you'll get C is equal to 36. Hence, we have 36 chickens in the farm. Okay, so any questions regarding the first category, logical thinking? If you have questions, you can ask in the chat box, or you can unmute yourself. And if you have no questions, please type none in the chat box so that I may know those who have questions or those who have none. How about the others? Okay, so if there are no questions for logical thinking, let's proceed to the next category, which is algebra. Okay. For number 7, find the value of y if 5x minus 4y is equal to 32 and x plus 4y is equal to 8. Now, the question asks for the value of y, right? However, it is easier to just add the two equations to eliminate y, solve for x, and then substitute it again later. So here, we add the two equations because, as you can see, you can just eliminate directly the variable y. So that would be 5x plus x is equal to 32 plus 8. 6x is equal to 40, or x is equal to 20 over 3. We divide both sides by 6 and simplify. Okay. Now we substitute to any of the two equations. So if you assess the two equations right now, it is much easier to substitute x in the second equation. So we have 20 over 3 plus 4y is equal to 8. We then multiply 3 to both sides of the equation to get rid of the denominator. Or yeah, you can just manipulate and then you multiply. So you have 12y is equal to 24 minus 20. We simplify, you have 12y is equal to 4. We divide both sides by 12, and you will get y is equal to 1/3. So the answer for number 7 is 1/3. Okay. Next, number 8. How many integral solutions is or are there for x if 7x plus 5 over 4 is greater than 12 but less than 29? Okay, so what we will do first is we get rid of the denominator in the middle of the inequality. So you will multiply both sides by 4. So that way we have 7x plus 5 is greater than 48 but less than 116. Okay, we then get rid of the constant. So how do we do that? We subtract both sides by, we subtract the whole inequality by 5. So you have 7x is greater than 48 minus 5, which is 43, and 116 minus 5 is 111. So 7x is also less than 111. We then divide both sides by 7. So that is our goal, to just have x in the middle of the inequality. So you'll have x is greater than 43 over 7, but less than 111 over 7. Okay, so how do we solve, or how do we count for the number of integral solutions? We express them as mixed fractions. So you have x is greater than 6 and 1/7, but less than 15 and 6 over 7. Now we look at the integers close to these boundaries, but follows the inequality. So that will be x is greater than or equal to 7, but less than or equal to 15. So hence, we have 15 minus 7 plus 1 is equal to 9 integral solutions. So if you are wondering why we have plus 1 here, that is because if we subtract 15 minus 7, we also get rid of 7, right? So we need to add that value again by adding 1. So that way we have 15 minus 7 plus 1, that is equal to 9 integral solutions. So the answer for number 8 is 9. Okay, for number 9. Find the value of real number x if the absolute value of x plus 7 minus the absolute value of 6 minus x is equal to 11. Okay, so the first thing that we will do here is to look for the critical values. These critical values will then divide our number line so that we can look up for possible values or sign changes later. So in this case, how do we get the critical values? You just equate this to 0. So x plus 7 is equal to 0 will give you x is equal to -7, and 6 minus x is equal to 0 will give you 6. So that means that we have a number line where we have -7 and we also have 6. So this number line will then be divided into 3. You have all values less than or equal to -7. We have all values greater than -7, but less than or equal to 6. And then we also have values greater than 6. Okay. So the first one, when x is equal to, when x is less than or equal to -7. So this is the first one. We have here negative of x plus 7 minus 6 minus x. Okay, so why do you have negative of x plus 7? That is because when x is less than or equal to -7, the value here becomes less than or equal to 0. So when we say less than or equal to 0, negative. So how do we get the positive value from a negative value? We multiply by -1. So in this case, we multiply by -1 here. So that is why we have negative of x plus 7. And then for absolute value of 6 minus x, when x is less than or equal to -7, this of course returns positive values. That is why there is no sign change. So we still have negative -6 minus x. Okay, we then have to simplify. Now, if we look at the sim when you simplify this one, this becomes negative x minus 7 minus 6 plus x. You get rid of the variable x and you will have -13, right? However, -13 is not equal to 11, which means that you can just get rid of the solution set. So that is not included. Next, when x is greater than -7, oh wait, I could just erase this. Okay. So when x is greater than -7 but less than or equal to 6, you have x plus 7. So of course that will become positive. Minus 6 minus x, so still positive, is equal to 2x plus 1. Because you have 7 minus 6, 1. X plus x, 2x. 2x plus 1 is equal to 11. We then solve for x. So you have x is equal to 5. That is because that becomes 2x is equal to 10. So you have x is equal to 5. Now, when x is greater than 6, you have a positive value for x plus 7, however, a negative value for 6 minus x. Because as x increases, 6 minus x decreases. As x becomes greater than 6, the value that it returns becomes negative. So that is why you multiply 6 minus x by -1. However, since we have subtraction here, so if you subtract a negative value, then of course that becomes positive. So you have x plus 7 plus 6 minus x. Okay, so we get rid of x minus x, and then you will have 13. However, 13 is still not equal to 11. So that means that the only value for x here is x is equal to 5. Hence, we have 5. Okay, so that's it for number 9. Next, we have number 10. Factorize 3x squared minus 12y squared minus 12x plus 12. Okay, so the first thing that we will do is to factor a common let's say a common factor. So what is the common factor? That is 3. So we can factor out 3, and you will get 3 multiplied to x squared minus 4y squared minus 4x plus 4. Now, if you take a look here, you will have x squared minus 4x plus 4. That is a perfect square trinomial. This is also a perfect square. And as you can see, it is a negative value. So that means you will later have a difference of 2 squares. So that becomes 3 multiplied to x squared minus 4x plus 4 minus 4y squared, which can then be expressed as x minus 2 quantity squared minus 2y raised to 2. Okay. Now for difference of 2 squares, if you have, let's say, a squared minus b squared, that will just give you a plus b multiplied to a minus b. So if this is a and this is b, then you can just write it as 3 multiplied to x minus 2 plus 2y multiplied to x minus 2 minus 2y. Okay. Or you'll have 3 times x plus 2y minus 2 multiplied to x minus 2y minus 2, or 3 multiplied to x minus 2y minus 2 multiplied to x plus 2y minus 2. So that is for number 10. Okay, let's move on to number 11. Given that x is a real number, find the minimum value of x squared plus 8x plus 10. Okay, so for this one right here, imagine x squared plus 8x plus 10 as, let's say, a function, right? If you try to graph that one, that will become a parabola. A parabola opening upwards because the coefficient of x squared is positive. Now, that means that if it is a parabola opening upwards, then of course, you are sure that there exists a minimum value, right? So there exists a minimum value. Now, what will you do here? We use completing the square. So how do you complete the square? So the first thing here is we have x squared plus 8x plus 10. We then look at the coefficient of x, that is 8. We divide 8 by 2 and then you square the value. So that will be 8 divided by 2, that is 4 squared, which gives us 16. So that means in order for us to have a perfect square, we must add 16 to the um, expression. However, if you add 16, we must also subtract 16. That way, we preserve the original value of the expression. So that becomes x squared plus 8x plus 16 plus 10 minus 16. And as you can see, we can already express this as a perfect square. So you will have x plus 4 quantity squared minus 6. Now, okay, so what we will do? What will we do after? It says here, it attains minimum when x is equal to negative 4. Now, why is that? Okay, so please take note that a perfect square, let's say a squared, perfect square, that is always greater than or equal to 0. It is a non-negative expression. When we talk about, let's say, real numbers. So that means that the minimum value a squared must have is 0. So that means that we must have this perfect square as 0. That is why it will attain minimum when x is equal to -4. That becomes 0 squared minus 6, which is equal to -6. Hence, the minimum value for 11 or for this given expression is -6. So that is number 11. And for number 12, given a and b are real numbers and satisfy equations, a minus b is equal to 9, ab is equal to 11, find the value of a squared plus b squared. Okay, you are given a minus b, the difference. You are also given the product. And you need to find this one. Now, what algebraic expression can you find where you can find these three? It is actually the perfect square trinomial, right? Because if you have a minus b quantity squared, you will have a squared minus 2ab plus b squared, or a squared plus b squared minus 2ab. So as you can see, we already have a value for a minus b, we have a value for ab, and we just need to substitute the 2 in order to get a squared plus b squared. Okay, so let's go over the solution. So wait, let me just move this one here. So you have a minus b quantity squared that is equal to 9, 9 squared. So simplifying, you will get a squared minus 2ab plus b squared is equal to 81. We then just substitute. So we have a squared plus b squared is equal to 81. We moved negative 2ab to the right-hand side of the equation. That becomes positive, right? And then you substitute ab is equal to 11. So you have plus 2 times 11. So that means that a squared plus b squared is equal to 81 plus 22, which is equal to 103. So the final answer for number 12, or the value of a squared plus b squared, is equal to 103. Okay. So before we move on to the next category, any questions? If you have questions, then you may ask them for free. If you have no questions, just type none in the chat box. Okay, so for 11, there. You can just take a screenshot. Nine, this one. Okay, so if there are no more questions, I guess we can proceed with the next category, which is number theory. Okay, so for number 13, find the last digit of, so we have it here. Find, wait. So we have it 4 plus 10 plus 28 and so on, plus 3 raised to 11 plus 1 plus 3 raised to 12 plus 1. Okay, so what shall we do with this one? Okay, so the main trick here is that we just have to follow this one. Okay, this form. You have 3 raised to n plus 1, where n starts from 1 and then ends with 12. So that means we have 12 addends. We then group all the powers of 3 from 1 to 12, and then we group all of the ones. Okay, so that would be a modulo 10. Oh no, it's not a. However, let's just let this as a. So that will be 3 raised to 1 plus 3 raised to 2 and so on until 3 raised to 12 plus 1 times 12, because as we have already discussed, we have 12 addends. Now under modulo 10. Okay, so take note that we have 12 terms here. 12 terms. Now if you try to look at the pattern for the units digits or the last digit for any powers of 3, you will have 3 raised to 1. So you have 3. 3 times 3, 9. 9 times 3, 27. So you just get 7. 7 times 3, you get 21. So 1. So we have four possible um, last digits for powers of 3. Now, since we have 12 consecutive powers of 3, then we have 3 sets of 3, 9, 7, and 1. So you have 3 plus 9 plus 7 plus 1 times 3. And then 1 times 12 is 12. However, 12 under modulo 10 is 2. Okay. Next, we have 3 plus 9 plus 7 plus 1. Okay, so this is a typo. It's actually 3. So that will be 20. 20 times 3 plus 2 modulo 10. Now, 20 under modulo 10 is 0 because 20 is divisible by 10. That means that this will just be 0. So that we are left with 0 plus 2 modulo 10, which is just 2 modulo 10. So that means that the last digit of the sum is 2. By the way, we apply congruence modulo 10 when we are to find the last digit or the units digit of a certain value or certain expression. Okay. So that's it for number 13. For number 14, find the remainder when 59 raised to 12 is divided by 7. Okay. So the thing here is we first start with the base. We first start with 59. We apply congruence modulo 7 to 59. So that is, so we have 59 raised to 12 modulo 7. That is congruent to 3. 59 divided by 7 will give you a remainder of 3. So 3 raised to 12 modulo 7. Now, what we can do here is we can express 3 raised to 12 into equal, let's say equal value, and then apply modulo 7 again. Because this is quite hard to simplify. 3 raised to 12. I know it's not quite hard, but it's tedious. It's time consuming. So what you can do is you express 3 raised to 12 as 9 raised to 6, because you can just have 3 raised to 2 raised to 6, right? 3 raised to 12 is equal to 3 raised to 2 raised to 6, which then becomes 9 raised to 6. Now, 9 under modulo 7 is just 2. So you have 2 raised to 6 modulo 7. And then, well, you can actually simplify this already, but what you can do is you can also express 2 raised to 6 as 2 raised to 3 squared. So that becomes 8 squared modulo 7, which becomes 1 squared Let's try. Hmm. So we have, let's say 8 modulo 7, and then it will just give you um, 1 modulo 7. Okay. So the remainder is actually 1. Okay. So let's move on to number 15. If x plus 3 is a factor of polynomial 135 x squared plus 222x plus c, find the value of c. Okay. So what do we do here? We will use factor theorem. Now, what is factor theorem? So factor theorem states that if you have a monomial, let's say x minus c is a, oh no, let me just use x minus a just to get rid of any confusion with that c. So x minus a is a factor of polynomial p of x if and only if. So that means it goes both ways, right? If and only if p of a is equal to 0. So that means if you substitute a to the polynomial, and if it will give you a value of 0, then that is a factor of the polynomial. So applying this one to the problem, you will have p of -3. So as you can see, a here is -3 because you can express this as x minus -3. Okay, x minus -3. So you have p of -3 is equal to 135 multiplied to -3 squared plus 222 times -3 plus c is equal to 0. Now we can just simplify that as c plus 549. So what we can do here is we can factor out -3, and you will have 135 times -3 plus 222. If you are to um, simplify much faster. So you'll have -3. So what is 135 times -3? That is just 5014, -405 plus 222. So that will just be -3 multiplied to -405 plus 222. So that is just 183, -183 times -3. So that is 549. So that is why you have c plus 549 is equal to 0. Now, solving for c, you will have c is equal to -549. So that is the value of c for the polynomial. Also, if you try to divide, it really works. Anyways, let's proceed to number 16. Given x is greater than 0 and x plus 4x over 3 is equal to 21, find the value of 19x. Okay, so this one is easy, as you will just multiply the whole equation by 3. This will give you 3x plus 4x is equal to 63. Simplify, and you will get 7x is equal to 63. you divide both sides by 7, and you will get x is equal to 9. Now for this one, you can just substitute it to 19x. So you will have 19x is equal to 19 times 9, which will give you 171. So the final answer for number 16 is 171. Okay. For number 17, if x is congruent to 7 modulo 13, find the maximum value of this two-digit number. Okay. So the easiest way, yes, yes, last number, this one, number 16. Okay. Any questions? Yes. So what we just did here is we just solved for x. So since we have an equation, x plus 4 over 3, 4x over 3 is equal to 21, we just have to multiply the equation by 3 just to get rid of the denominator. So you have 3x plus 4x is equal to 63. Simplify 3x plus 4x, that will be 7x is equal to 63. And then we divide both sides by 7. That will give you x is equal to 9. And then you just substitute x is equal to 9 to 19x. So that will be 19x is equal to 19 times 9, which will give you 171. That is number 16. Okay, so for number 17, what is modulo? Okay, so modulo is, let's say, an operation wherein it tackles more on the remainders and divisors rather than the quotient. So let's say I have x is congruent to 2 modulo 3. That just means that when x is divided by 3, it will give you a remainder of 2. So this will be on the left side, that will be the remainder. And on the right side of the modulo, that will be our divisor. So as you can see, you can clearly see that there's actually no quotient, right? However, we can express um, the remainder as, of course, any value that will be congruent to this expression. Now, I will also explain how do we solve this one for number 17. So in this case, we have x is congruent to 7 mod 13, right? If we were to express this into algebraic expression, that is equal to 13k plus 7 for some integer k. So as you can see, 13 is the divisor, right? So 13 times k, because if you try to divide by 13, of course, the answer will be the quotient. So let's say k. And then we add 7, because 7 is the remainder. So that is why x can be expressed as 13k plus 7 for some integer k. Next, the question asked, find the maximum value of this two-digit number. So that means that 13k plus 7 should be less than or equal to 99, because the maximum two-digit number is 99. Okay, so here we solve for the value of k. So 13k is less than or equal to 92. So you just subtract both sides by 7. And then we divide. So k is less than or equal to 92 over 3. which is equal to 7 and 1/3. So what integer is close which is closest to 7 and 1/3 but less than 7 and 1/3? So that is 7. So k is equal to 7. So we have 13 times 7 plus 7 is equal to 98. And as you can see, this will be our largest two-digit number, x. So the answer for number 17 is 98. So that is how you express into algebraic expression or equation. Next, number 18. Find the sum of positive factors of 2023. Okay, so we already know how to solve for the sum of positive factors. The first thing that we will do is try to express 2023 into its prime factorization. Now, this will be very helpful for you. You must familiarize the prime factorization of 2023. So 2023 is equal to 7 times 17 squared. Because usually in exams, right, you can clearly see the references for the values, as most of them uses the year. So you have 2023. So I highly advise to familiarize the prime factorization of this one. So 2023 is equal to 7 times 17 squared. We have, so what we'll just do, we get the prime, we add the powers of the prime factors from 0 until the value here. So as you can see, we have 7 raised to 1. So we start with 7 raised to 0 plus 7 raised to 1. So that is the first value. Next, we have 17 squared. So you start with 17 raised to 0 plus 17 raised to 1 plus 17 raised to 2. And then you just simplify. So 7 raised to 0 plus 7 raised to 1 is equal to 8. 17 raised to 0 plus 17 raised to 1 plus 17 squared, that is 307. So if we were to simplify this one, it will give you 2,456. So that is the answer for number 18, 2,456. Okay, so any questions regarding number theory? Numbers 13 to 18. If you have questions, please feel free to ask. If you have no questions, please type none. Nothing. Number 14. By the way, okay. Number 7. I think this is number 17. And then I'm just gonna go to number 14. How about the others? 15, 14. So this is 14. Okay. So since there are no more questions, we can have our 10-minute break, everyone. So, 13. You want 13? Okay. So for those of you who have no questions, we may take your break. Please be back 10 minutes after. Okay. And then please type ready in the chat box so that I may know who are done the with their breaks. Okay. So see you 10 minutes after. Okay, so hello everyone. Are you guys ready to continue? You guys are ready? Please type ready in the chat box so that I may know who's how many of you are done or are ready to continue. Okay, so let's continue with geometry. Okay, so for number 19, the radius of a sector is 10 centimeters and its central angle is 50. So we know what a sector is, right? So a sector is a part of a circle. So as you can see, if you have a circle and let's say you have a radius 10, so and you also have a central angle of 50. So if this is 90, this is 45, and something around there. So you have 10, have 50 degrees. So, oh wait, is my presentation busy? Can you see the annotation? Hello, everyone. Can you see the presentation? Okay, thank you. So, as you can see, this is the sector. Wait, this one right here. I'll just shade it into something like this. So something like a pizza slice. So that is the sector. Now, given a triangle with area 2 pi square centimeters, at most how many triangles of the same shape can fit into the sector? So basically, you just divide, right? So how do you find the area of a sector? So that will just be, you just compute the total area of the circle. So that is pi r squared, right? So you have 10 times 10 squared. And then you multiply it with 50 over 360 because what we only need is 50 degrees out of the whole 360. So you have 50 over 360. Now that is supposedly greater than 2 pi times n, where n is the number of triangles that has an area of 2 pi. So if we simplify this one, it will give you 125 over 9 pi is greater than 2 pi n. So if you simplify 110 squared, then you have 50 over 360, you'll have 125 over 9. Okay. So next, we divide both sides by 125. I know you divide both sides by 2 pi. So that way you can actually divide out pi. Oh no. And then you have 125 over 9 divided by 2. So you have 125 over 18. Now 125 over 18 is equal to 6 and 17 over 18. So that means that we have 6. We only have 6 triangles of the same shape that you can have inside the sector. So just familiarize this formula. So the formula of a sector is just area of the circle multiplied um, by the ratio of its central angle to the whole circle. So 50 over 360. Okay. Next, we have number 120. I don't know, it's number 20. Sorry. So if a straight line L passes through A 465 and the slope of L is -5, find the x-intercept of L. So what do we do first? We let x0 be the x-intercept, because if you have an x-intercept, its y-coordinate is equal to 0. So you just let it x. Next, we use the formula of the slope, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Or usually we call it as rise over run, right? So you have 0 minus 65 divided by x minus 4, that is equal to -5. We then have to solve for x. So you multiply both sides by x minus 4, and you will get -5 x plus 20 is equal to -65. If you subtract 20 to both sides of the equation, or from both sides of the equation, you will get -85. Now, -85 divided by 5 will give you x is equal to 17. So that means that the x-intercept is 17, 0, or 17. So that is number 20. Now for number 21. If the lengths of the sides of a triangle are 9, 40, and 41, find the area. Okay, number 19. Yes. So what we just did to number 19 is compute the area of the sector, and then knowing that a triangle is somehow pointy, right? A pointy polygon. It does not have any curves. Then that means that if you try to imagine, you cannot actually cover all of the sector. That means you have a greater area than um, if you are given a number of triangles times its area. So that is why you have greater than instead of greater than or equal. Okay. So 21. Okay, so we are given three sides and then we find the area of the triangle. Okay. So actually, sometimes it is very beneficial for competitors, or what you call this, participants, to know um, let's say Pythagorean triples, because that will save you a lot of time. Okay? If you are familiar with many Pythagorean triples, let's say for example number 21. If if I don't know that 940 and 41 is a Pythagorean triple, then what will I do? I will use Heron's formula to get the area, right? You just get the semi-perimeter and then you solve. You substitute it to the formula. However, note that the triangle is a right triangle. So it is a Pythagorean triple, since 9 squared plus 40 squared is equal to 41 squared. So that means in order to get the area of this right triangle, I just have to substitute 9 and 40 to the formula of the area. So the area will just be 1/2 times 9 times 40. So 1/2 times 9 times 40 is equal to 9 times 20, which is equal to 180. So the area of the triangle is 180. So it saves you a lot of time, right? If you are familiar. Also with multiples of Pythagorean triples. Like let's say 15, 20, 25. Yeah, you can use Heron's formula, but um, that is, yeah, it is beneficial to, let's say, familiarize Pythagorean triples. Well, actually, you can also use Arrow's formula. It will give you 180 still. But you have to go through semi-perimeter and then the formula. So, okay, let's move on to number 22. Find the area of the triangle with vertices x 5, -2, y -1, 5, z 3, 8. So what I will do here is I could just use shoelace method, or I forgot the term the for this one. So what I will do here is the area is equal to 1/2. So I will arrange the coordinates in vertically. So I would have 5, -2, -1, 5, 3, 8, and then I would go back to 5, -2. Okay. So why is this called shoelace method? That is because in order to get the area, you must add all the product of this one. 5 times 5, -1 times 8, and 3 times -2. And then you subtract the area, I mean the sum of the products of -1, -2, 3, 5, and 5, 8. So as you can see, um, looks like a shoelace. So we have area is equal to 1/2 multiplied to the absolute value of 5 times 5, as you can see in the blue arrow, plus -1 times 8, plus 3 times -2, minus -1 times -2, plus 3 times 5, plus 5 times 8. Okay, simplifying, we get 1/2 times the absolute value of 5 plus 5, 25. -1 times 8, -8. 3 times -2, -6. -1 times -2 is 2. 3 times 5 is 15. 5 times 8 is 14. Okay, so 25 minus 8 minus 6, that will be 11. So 11 minus 57 is -46. But since we have absolute value, so you have area is equal to 1/2 times absolute value of -46, which is just equal to 23. So the area for number 22 is 23. Okay, so let's move on to number 23. So x7 is the midpoint of A, 1 -y, and B, 35, -15. Find the value of xy. Okay, so in order to compute for the midpoint, right? So the midpoint of two terms, let's say if you have A, no, yeah, if you have A, you have AB, and you have C, you have CB, then the midpoint of A and C, so M, is equal to the averages or the midpoints of each coordinates. So you have A plus C over 2, and you have B plus D over 2. So we will use this formula. Okay, wait. So in this case, the first one, midpoint X is equal to 35 plus 1, right? The X coordinates, sum of the X coordinates, 35 plus 1 divided by 2. Now for the Y coordinate of the midpoint, we have 7 is equal to -y plus -15, or -y minus 15, and then divide by 2. So we'll solve for X and Y. So for X, we have 36 over 2, which is equal to 18. Now for Y, we have -y minus 15 is equal to 14. So that means that we have y is equal to -15 minus 14, which is equal to negative 29. That is why we have negative 29. So the sum x plus y is equal to 18 minus 29, which is equal to negative 11. Okay. So that is number 23. And for number 24, the hypotenuse of a right angle triangle is 28. So find the maximum area of the triangle. Okay, so if you are given a right angle triangle and you need to get the maximum area, then it must be an isosceles right triangle. So we attain the maximum area when the triangle is an isosceles right triangle. So that means that two of the sides of the right angle triangle, aside from the hypotenuse, is equal. So that is a squared plus a squared is equal to 28 squared. So that means you will have 2a squared is equal to 784. Now, we don't actually need to solve for a. What we just need is a squared. Because if you have a right triangle, the area later on will just be 1/2 times a, or just 1/2 a squared. So what we just need is a squared. So if you divide this by 2, you will have a squared is equal to 392. Now the area will just be a is equal to 1/2 a squared is equal to 1/2 of 392, which is equal to 196. So that is the maximum area of the triangle, 196. So that is number 24. So any questions regarding geometry? Number 19 to 24, right? 19 to 24. Yeah, 19 to 24. Any questions? If you have questions, please type it in the chat box. If you have no questions, please type none. So, okay, gone. Okay, so let's proceed to the last category, which is combinatorics. First one is 32 cards are marked from 1 to 32, and 2 cards are drawn at random without replacement. So find the probability that the sum of two of these numbers is odd. Okay, so actually, there are 16 odd numbered cards and 16 even numbered cards because we have 1 to 32. Now, for us to have an odd sum, we must have one even and one odd card. Right? So that is the only case. So what we just have here is just choose one out of 16 odd numbered cards. You multiply that to choose one out of 16 even numbered cards. And then you divide it with the total number of combinations uh, of choosing 2 out of 32 cards. So if you simplify this one, 16 choose 1 will just be 16 factorial divided by 1 factorial, 15 factorial, which is just 16 times 15 factorial over 15 factorial, or just 16. So that is why you have 16 times 16 here. Now for 32 choose 2, that will just be 32 factorial divided by 2 factorial, 30 factorial. That will give you 32 times 31 times 30 factorial divided by 2 times 30 factorial. So that is why you have 32 over 2, which is 16 times 31. Now, it's okay not to simplify that first, not yet, because as you can see, we can divide out 16 from the numerator and denominator. Okay, so that means that you will have 16 out of 31. So 16 over 31 is the probability. So it says here you can choose any card as your first card, and there are 16. Yes, out of the 31. But, as long as you know this case, for two cards to have an odd sum, then you must have one even and one odd. Okay, so that is the final answer for 25. For 26, one set of poker have 52 cards, which have four suits, spades, hearts, diamonds, and clubs. Okay. And 13 values. So we have 13 values. So values and numbers are not the same. Okay. So we have A, 2 to 10, Jack, Queen, and King, of which 2 to 10 are numbers. So as you can see, it already says 2 to 10 are numbers. So find the probability that two cards drawn without replacement are of the same suit and their values are consecutive numbers. Okay, so the first thing that we will do here is to count how many possible um, combinations can we have for consecutive numbers. So you have 2, 2 and 3, 2, 3, 3, 4, until 9, 10. So how many combinations is that? So you have 2 to 9. 2 to 9, that will just be 9 minus 2 plus 1, which is equal to 8. So there are 8 possible ways to have consecutive numbers. Now, since the two cards must have the same suit, then of course you will have 4 times 8, right? And then you just divide that with how many ways you can choose 2 cards out of 52 cards. So that will just be 52, choose 2. So we use combination here because we only have 8 here. With order doesn't matter. So that is why we have 32 divided by 52 choose 2 is just 52 times 51 over 2, which will then be simplified as what 26, right? 26. So wait, let me just change this one. So I will have 32 times 2 divided by 52 times 51. So how do you simplify this one? So 52 is divisible by 4. So that will be 13. So since the numerator is divisible by 4, you will have 16 over 13 times 51, which will give you 16 over 663. So wait. Here. So the final answer will be 16 over 662. So that is number 26. For number 27, it is known that A, B, C, D are integers greater than 0. Take note, greater than 0. So find the number of solution sets for A plus B plus C plus D is equal to 7. So what integers um wait a minute. Okay. So what integers what do you call integers that are greater than 0? So those are positive integers, right? So since we have this one, then we can use stars and bars. Now the stars and bars formula for positive integers is just n minus 1 choose k minus 1, where k is the number of possible slots here and n is the total value here. So that would mean you will have 7 minus 1 choose k minus 1. So 4 minus 1. That will be equal to 6 choose 3. So 6 choose 3 is just equal to 6 factorial over 3 factorial, 3 factorial. Now we can divide out 3 factorial. We have 6 times 5 times 4 over times 3 factorial divided by 3 factorial, 3 factorial. So you can divide that out. 3 factorial is equal to 6, which means that you will have 5 times 4, which is 20. So we have 20 solution sets, positive solution sets for 27. So that is number 27. Okay, so let's move on to number 28. If A and B are positive integers and 2AB minus 5A plus 8B is equal to 45, find the number of solutions for A and B. So in this case, our aim is to factor this one out. That way, we can assign values of factors later on. Now, the first thing that you must notice is that A and B are separated here, the variables A and B. So that means that you have A and B here. Now the problem that is left is where should you put 2? Because you have 2AB. So should 2 be here or should 2 be here in B? So let's try to assess the coefficients of A and B. So we have here -5 and we have here 8. So which of these two are even or is even? So -5 and 8. So of course, the even one is 8. So that means that 2 will be here with B. Now the next thing here is how do you get -5A? So we already have 2AB. This is already 2AB. So how do you get -5A? So you have to have here -5. So that is -5A. Next, how do you get 8B? So you must have +4 here. And since you are multiplying two binomials with different, let's say, different variables, then you must expect 4 terms here. However, you only have 3. So, which means that we are lacking something, which is 4 times -5, which is -20. So that means that we must add -20 to both sides of the equations. So you will have 45 minus 20 And you will have here 2ab minus 5a plus 8b minus 20. So for the left hand side, you can now factor it as a plus 4 multiplied to 2b minus 5. And as for the right hand side, this becomes 25. Okay. Now take note that a plus 4, a and b are positive integers. That means that a plus 4 is greater than 4. So the only possible factors that is possible for, only possible factors of a plus 4 or values of a plus 4 should be 5 or 25, right? Because we need to assign factors of 25. So if a plus 4 is equal to 5 and 2b minus 5 is equal to 5, then we have a is equal to 1 and b is equal to 5. The other one, if a plus 4 is equal to 25 and 2b is equal 2b minus 5 is equal to 1, then this becomes a is equal to 21 and b is equal to 3. So which means that the number of solutions AB is equal to 2. So there are only two possible solutions. So the answer for number 28 is 2. Sir, after thinking about it, I still don't get number 26. Okay, sure. We can go back to number 26 later. So the answer for number 28 is 2. Okay, so let's proceed with number 29. Find the number of three-digit numbers such that the hundredth digit is larger than the tenth digit and the tenth digit is larger than the unit's digit. Okay, so the first thing, of course, is we know that A is greater than B is greater than C. Right? So we'll start with, of course, 9. So how many possible values for 9? How many possible values for B? We have 8, 7, 6, until what number? 1. Because you can't have 0. So for the values of C, for 9, 8, how many is it? For this right here, we have 0 to 7. So you have 8. For this one here, 0 to 6. So you have 7. For this one, 6. Right? And so on until 1. So you have 1 plus 2, 1 plus 2 plus 3, and so on until 8. So that will just be equal to what? N times n plus 1 over 2. So you have 8 times 9 over 2. That is equal to 36. Right? Wait, let me check. Okay. So how about 8? So for 8, we have 7 until 7, 6, 5 until 1. So how many values here? So you have 0 to 6, still 0 to 6. So you have 7. And then we have here 6. So as you can see, there is a pattern, right? So until here, it will be 1. So the pattern will just be from 9 to 2, because the last one will be 210. So the pattern here will just be sum of 1 to 8 plus sum of 1 to 7 plus sum of 1 to 6 plus sum of 1 to 5 and so on until 1. If you have B, yes, you can actually have C is equal to 0. That is why I only have 1 here. You have 0. So only one case. Okay. So here, so you have, okay. So since you already know the pattern of the values, then the final solution will just be something like this. 8 times 9 over 2 plus 7 times 8 over 2. So this is the sum, right? Until um n times n 2 plus 1 times 2 over 2. Okay. So if you factor out 1/2, so you will have 8 times 9. No, don't factor 1/2. It will just ruin your solution. So that will be 4 times 9, 36, plus 7 times 4, 28, plus you have here 6 times 7, so 21. Next, we have, how many is that? 6 times 7 and then 5 times 6, so 15. We have 4 times 5, 10. 3 times 4, 3 times 4 is 6 divided by 2. Okay, that is divided by 2. And then 2 times 3 is 3. And then 1 times 2 is 1. So you have 36 plus 28 plus 21 plus 15 plus 10 plus 6 plus 3 plus 1. So how many do we have? Let me just check. If you have 3, right? 3, 3 to 1, 3 to 0, and then you have 310. Yeah, so it's correct. You have 3. So 36 plus 28 plus 21 plus 15 plus 10 plus 6 plus 3 plus 1. The answer is 120. So you have 120. So the answer for number 29 is 120. Hmm, let me just check for other values. Okay. So the answer is 120, correct? Oh, yes, yes. Excuse me. Yes. Any questions? No, someone messaged me. Yes, what's the matter? A video. Okay, so don't worry about the video, guys, because it will be sent. It will be uploaded in our Google Drive. Okay, so you will have access to it later. So the answer for number 29 is 120. So next, we have number 30. We will go back to the previous number later. Number 30, a fair six-faced die is thrown 3 times. A PDF, I think yes. It will also be uploaded. But to be fair, you can just review the video as I have explained it better in the video than in the solution manual. Okay. So here, a pair six-faced die is thrown 3 times. Find the probability that the product of numbers obtained is 18. So what possible what do you call this? Possible values for a six-faced die will give you a product of 18. So you will have 18 is equal to um, 2 times 3 squared, right? 2 times 3 squared. So that will be the probability that you will have 136 and the probability that you will have 233. And I think that's it, right? So what is the probability of having 1, 3, and 6? So that will just be hmm, I just this done one by one. Oh yeah, you just have to familiarize. Yes. Okay, so for this one, the probability will just be 3 factorial divided by 6 cubed. Now the reason for this is we have 3 factorial ways to arrange 1, 3, and 6, and the denominator is just 6 cubed because 6 face die thrown 3 times, you have 6 times 6 times 6, right? So for P, you have 3 factorial over 2 factorial multiplied to 6 cubed. Now why do we have again 2 factorial? Because we have two values here that are identical, which means that you must divide the number of arrangements by the number of identical values, factorial of the number of identical values. In this case, we have 3 factorial over 2 factorial, and then you divide it with 6 raised to 3 again. So this becomes 1 over 36, right? And this becomes 3 factorial, so 6 squared, 1 over 72. So if you add the two, you will have 72. Wait, I'm just gonna write it here. 1 over 36 plus 1 over 72. That is equal to 2 plus 1 over 72. That is 3 over 72, or 1 over 24. So the answer for number 30 is 1 over 24. Sir, why 3 factorial? Okay, so we have 3 factorial in the numerator because that is the number of arrangements for 1, 3, and 6. Okay, so you have to count the number of arrangements. So same with 3 factorial over 2 factorial here in the second one. Okay, so that is the answer, 1 over 24. Can I out now, please? Wait, let's just go back to some problems, and then I think I can let you go. Okay, so for 27, so this is just stars and bars. So since this is greater than 0, then you can use the formula for stars and bars for positive integers n minus 1, choose k minus 1. So that will be 7 minus 1, choose 4 minus 1. Because there are 4 here, and we have a total of 7. So 6, choose 3, which when simplified will give you 20. And also for number 26, okay, so for number 26, the way to do here is to count the number of possible combinations for consecutive numbers. So we have, let's say, so the numbers here are just 2 to 10, right? Of which 2 to 10 are the numbers. So you have 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, and 9, 10. 9, 10. So there are 8 possible. Is 8. And then since there are 4 suits, so you have to multiply all of the 8 of them by 4, and then you just have 52, choose 2 in the denominator. So that will just be 32 divided by 52 times 51 over 2. Okay. And then you can just simplify that to be 16 over 663. So that is the final answer for 26. Also, for number 28, you just have to factor this one. So in order to factor, you will have a 2b, and you will have, I think this is a plus 4, and then you have 2b minus 5. Now, since we need to factor this one, we are lacking negative 20, right? So we must subtract negative 20 on the other side, which will give us 25. A plus 4 multiplied to 2b minus 5 is equal to 25. Now, please take note that a is a positive integer. That means that a plus 4 is always greater than 4, which means that the factors that can be assigned to a plus 4 will only be 5 and 25. Okay, so if a plus 4 is equal to 5 and 2b minus 5 is equal to 5, then you will have a is equal to 1 and b is equal to 5. However, if you have a plus 4 is equal to 25 and 2b minus 5 is equal to 1, this will also give you a is equal to 21 and b is equal to 3. So there are two number of solution sets. Okay, so that's it. Questions, everyone, clarifications. If you have questions, please type it in the chat box. If you have no questions, please type none. Now it's okay if you don't have screenshots because the video will be uploaded. So you can just watch the video and then just take the screenshot there. Okay. Okay, so if there are no more questions, so thank you everyone. I hope you've learned a lot this session, and good luck on your TIMO examination. Okay, so the links to the drive will be sent to your email. So
could
just
you
wait
turn
for
back
that.
number 1, 2, 3, and 4? I want to
Okay.
take a picture.
Okay, so
Okay.
yeah, I think we can go back to the number. Wait. So by the way, guys, for those of you that will leave, so bye everyone. Take care and have a wonderful evening. So here, 4. So this is for number 1. Bye, guys.
Bye, sir. Thank you.
Thank you. So, oh yeah, that is number 1. Goodbye.
And number 2.
No, that is number 2.
So solution.
This is just actually logical thinking. You don't have to write too many lines for the solution.
Okay, and then number 3.
Number 3.
Okay.
Number 4.
I have number 4 already. Okay,
Okay.
thank you. Thank you so much.
Thank you.
Thank you.
Good luck. Bye.
Thank you. Okay, bye-bye.
Bye, everyone. Good luck on TIMO. Fighting.
Okay, thank you. Thank you for your help.
You may now leave the meeting, guys. Thank you. Bye. Have a good day also.